All right. Well, welcome everybody back to our session after the break. To try and keep us on time, I'm going to go ahead and get us started here. So next up in our session, we're fortunate to have Dr. Jason Archer back to the podium again. And he's going to tell us about using methane information in balanced beef breeding decisions.
Thanks, Megan, and thanks everyone for coming along. So Matt Spangler actually asked me to talk about balanced beef breeding decisions, and there's really one key slide that I wanted to talk about, but then I looked at the program and saw it allocated me about 40 minutes, which I can't do on one slide. I can't talk that long on one slide. So I will give you a little bit more detail about some of the other aspects of what's happening. And it does say balanced beef breeding decisions because that's what we're talking about here. But actually, in actual fact, as you probably saw this morning if you're in the session, we've made a whole lot more progress in sheep. And so I'm pretty much going to talk about what we do in sheep with the assumption that we're going to do something pretty similar in beef. And then at the end, I'll maybe just speculate about one or two things that might be different. So yeah, it could be a misnomer, the beef breeding decisions, but that's it. So firstly, I'll just talk a little bit about the strategy underpinning selection to reduce methane. There's nothing, no rocket science in that. A little bit about the methane measurements in sheep. Some comments about price sensitivity and who's going to pay, because that's where the rubber hits the road. And then the selection emphasis stuff, which is what Matt really did want me to talk about. And then just a couple of thoughts and options around methane BV formats, which we are still vigorously debating. And then a little bit about how might the commercial producer capture the benefit. So I'll just start with this slide, which again is borrowed from our Ministry for Primary Industries. And they are essentially, what this slide is doing is saying, what are all the technologies that we have in the pipeline that might apply to us in New Zealand, and where are they in terms of actual implementation? How far away from implementation are we? And you can see that pretty much the only one that's through the pipeline is sheep genetics. There is nothing else actually being done other than perhaps the eco pond, which is essentially a dairy effluent management system. So that's not much help to us as beef or sheep and beef producers in New Zealand. Obviously good for the dairy industry. And then actually one of the key questions, just work out which is this up here says stackability. And that's one of the key questions too, is to if we have low methane sheep and then we put, say, a rumen modifier in them or put them on some low methane ryegrass or something like that, are the effects additive? Are they multiplicative, which would be even better, or do they essentially almost cancel each other out? So that's one of the key questions in general for all these technologies. So that's just a little bit of an overview about technologies. So what's our strategy for genetic selection? So basically it has to be genomic selection, right? Because this is a hard to measure and expensive to measure trait. So we believe that we need to measure in sheep anyway, approximately 5,000 animals a year to provide a 20,000 animal reference population that's in the zone less than a couple of generations from the selection population. The sheep turn over a little bit quicker than cattle. So that's our goal, and we've had a project which is 40% funded by the government and 60% funded by us as the industry, and then a whole lot of admin added by the government. So you can probably mean that's probably a net 20% added by the government. And we have basically that's an implementation project which has done a few things, but the major thing it's done is just basically funded that methane trailer that I showed this morning to go around and to visit our seed stock sheep flocks and measure animals and accumulate information. The next part of the strategy hasn't really happened yet, but we need to find some proxy predictors so that we can perhaps do a few less of the gold standard pack chamber type measurements, but actually supplement that with more proxy predictor phenotypes. So as I say, that hasn't happened, but it could happen soon. And then obviously utilising genomic selection, so utilising that across the breeding population. And one of the challenges there is not every sheep flock in New Zealand utilises genomic selection for anything, let alone for methane. So there's an adoption challenge across a whole heap of these things. It's easy to talk glibly and say, yeah, this is all going to happen, but actually making it happen is somewhat of a challenge. So that's the overall strategy. I showed this slide, I think, this morning. So just to repeat, but I have actually got a video here of how it actually operates, and it's sort of interesting. If my mouse turns up. No sound, so I'll just have to provide the sound by the sound of it. So they're just pushing sheep there into those chambers. Sheep just waiting to go in the chambers. They go in there, they're pretty easy to handle, although probably the people that do it don't say that. And here they're just sampling gas from the top of the chamber, and it goes into what's called an eagle analyzer, which is used in mines, and they're writing down the results, and yeah, that's essentially the process. They go in there for 45, 50 minutes and then just come out calm as they've had a little rest for a while, and no one's too worried by anything. So again, it's the same principle as what I showed this morning for the cattle. So again, I showed this slide this morning, but really the point of this one is that we have been doing this in terms of actually calculating breeding values for industry since about 2019. And that was, I guess, based on the research data. And since then, we've been doing these 5,000 animals a year. It's probably got to the point now where we actually need to just have a look at our genetic parameters again, re-estimate those. We're going to do that soon, because it's all very well to do research information, but actually we just need to check that those parameters still hold for the industry measurements that we've been doing. And so this morning I showed some research results of a research flock. So what I've got on this slide is the results from two actual ram breeding flocks, and they're reasonably significant flocks in the New Zealand sheep improvement scene. And they're labelled there Cool Sheep A and Cool Sheep B. Cool Sheep's just the name of the project, but what we call the project to go out and measure all these measurements and get these breeding values. So we call it Cool Sheep, and we've got a beef project coming up called Cool Beef. So these flocks, you can see by these two indexes. One's what we call New Zealand maternal worth, which is just our base index, with some base productivity in there, and these flocks are making good gains on those indexes. And the other one is another index which has got facial eczema, which is a disease of sheep in the North Island of New Zealand, and internal parasite resistance. So they're making gains, particularly flock A in that, and then more laterally flock B is taking that on and doing that as well. So the point is that these flocks are making good genetic gain. So what's happened in terms of their selection? Well, you can see at the same time that they've been selecting and making good genetic gain for those productivity type traits. They've actually managed to decrease their per head emissions, and there's not a scale on that, so it's not that clear as to how much they've been able to decrease, but they certainly have made some progress. It's fair to say that of the flocks that we go to, so there would be probably 30 or 40 flocks that we measure every year. Not everyone is doing it with the idea at this point of making genetic gain. Some of them are doing it to see where they sit. Some of them are doing it to give options for themselves in the future. That's part of the adoption process, right? Though you've got to let people have a sniff at what's going on before they commit. But these two flocks have committed. Interestingly, the other point about this is that actually they started with quite different methane profiles, right? So one was emitting significantly more than another. And I don't know whether that's because they're larger sheep or not. Or there's probably another, could be another reason behind that. But in both cases, they've been able to make gains. And then there comes an issue around, well, who are you going to credit? What are you going to credit? Are you going to credit the absolute value, or actually are you going to credit the fact that you've made progress? Because if we only credit the absolute value, then flock B up there that started high and has made some good gains reducing their emissions, well, they'll miss out altogether, and why would you do it? So some of the things around incentivisation here and the way the government's going to treat people are quite key, and so that's sort of one of our roles is to take the arguments to government to say, well, actually, you know, if you were selling a whole heap of rams, and even if your methane emissions were higher, but you're lowering them, you're actually shifting the mean, just like the flock that started below the mean. So, so there's this thing here about costs and price sensitivity. So we've been covering the up until recently the entire cost of the methane measurement, and the breeder's been contributing a genotype, but obviously they get a whole heap more for that genotype than just participation in this project. They get genomically enhanced breeding values on all the traits they're interested in. The cost of the test is now about New Zealand $75, which is about US 42. So it's not cheap on a per head basis. It sounds cheap if you're talking beef cattle, but you've got to remember sheep are a lot smaller than beef cattle, and you have a lot more of them. So it's not that cheap. And what we found, so this year we didn't quite have enough money in the kitty to do 5,000 records, and we think we had people putting their hand up for that many, or maybe we had a few more. And we actually worked out that actually the fairest way to do this would be to spread it amongst the same people who were testing the money that we had, but we would then ask for a $16 contribution to the $75 from the breeders. Well, a reasonable number of them pulled out just at $16. So that is a pretty good indication to us around price sensitivity and the value that people are putting on this, or what they believe about who should pay for this, right? So these are all the challenges that we face, and these are real adoption issues, right? Because $16 a gain doesn't sound like much, but they're sitting there saying, well, I could spend $16 on this methane trailer coming up the driveway. So, and that's $16 times 168, because that's how many you do in a day. So whatever that is, it's $2,500, $3,000. I could actually spend that money on more genotyping, or I could spend it on all sorts of things. And actually our industry's been under a fair bit of financial pressure in the last year or two. It's sort of coming right just this year at the moment, but yeah, so it is pretty price sensitive, and you know, that's a bigger question as to who should pay. It's a question about genomics and phenotyping in general, I think, but it's particularly a pointed question here, because you know, you could make an argument that maybe the industry as a whole should pay, and that's what's been happening up until now. Or maybe you could make an argument that actually it's the government putting the requirement on us, so so the government should pay. You know, that whole debate is yet to play out, and yeah, we'll see where we land on that one. But in general, you know, our position, the New Zealand philosophy around subsidies is that the government doesn't do long-term subsidies; it just gets things going. So stepping up to pay for something like this in the long term would be a change of position. So this is the slide that that I was really going to talk about in terms of how do you balance methane and productivity. And so what this slide shows is, on the left-hand side is essentially the amount of progress that we could make in our New Zealand Maternal Worth Index, which is basically just our core productivity index. And on the right-hand side, and so that's the green line, on the right-hand side is the amount of progress that you could make in methane reduction. And as you increase the economic weight, or the weighting that emphasis that you're putting on methane, you get curves like this. And the shape of these curves and the absolute value of these curves depend very much on a heap of things, but one of them is the level of antagonism or not that you have between the two traits that you're talking about. So antagonism would obviously change the trade-off that you need to make, but we're really fortunate in this instance that that the antagonisms are not, there's not many there. So that's a bit of good luck, I guess you could say, and an opportunity for us. The absolute value of those curves, and these are not showing an absolute values, actually, they're relatives, but that also depends on how accurately you're measuring traits. So as you measure the trait more accurately, it would get more emphasis in an index, but you'd also make more progress overall, whether that's the index or the methane trait itself. But when you look at a trait like this or curves like this, you can then start to ask people, well, how much would you be prepared to give up in progress for your main index, for your productivity index, to get some progress in methane? And I suspect that's the way that we'll end up really going. It's more, I guess it's more a desired gains than a straight out economic decision. But you're really asking people, well, what are they prepared to do? What are they prepared to give up? And you can see there, if you went to around about that multiplier of 2, and that's a multiplier. There is an economic weight behind that, but I said before that our industry has got people that that don't like this, and we did get a bit of a beating for publishing what we would even be prepared to do. So the economic weight is sort of anonymised that we've got there. But if you took that value of 2 times there, you would essentially get probably 90% of the progress that we would otherwise make. And so that's progress going forward, right? It's not that we get 90% of what we currently do, it's 90% of our future gains. And we would probably make about 30–40% of what we could potentially make in terms of gains in methane. I actually put this curve to, we've got an advisory group with, I don't know, half a dozen or a couple more, eight or so sheep breeders on that advisory group, and I put this curve to them and said, right, where would you choose? And I probably sort of initially biased it by saying, I'm thinking about 2. And most of them went back to saying, well, about 1 might be right. So in other words, and these were reasonably enlightened sort of people too. But they're essentially saying, yeah, we'd probably give up 5% of our future gains to make some gain in methane. That was their initial response, which, yeah, that might change over time. Attitudes might change over time, or they might not. But at least there's a clear trade-off when you can look at a graph like this and you can say, well, this is where I want to be. So I think that's how we're going to go about balancing up our selection decisions. So yeah, it's not straight economics. If you put a potential future carbon price in there, it'll be scary. You'd end up right down the right-hand side of that graph, and all we'd be thinking about would be methane and nothing else, and that's not palatable to anyone that's breeding sheep. So I think we could do the same in cattle. Obviously, we would be having to redo those curves based on any antagonisms that we find or don't find. But it's an approach that I think that we'll use for cattle as well, in terms of providing directions and breeding indices. And people are trading, even if they're not using indexes, they're doing these trade-offs in their mind all the time anyway. So how much am I prepared to give up on one trait or a bunch of traits that make up my productivity to get a gain in another trait? So people do that intuitively anyway. There is a question about the methane BV format, and I'll just remind you of what I was talking about before this morning, really in terms of what we're trying to achieve. And really, I think what we need to be focusing is on the methane yield. So that's methane per kilo of feed. Obviously, it is also good to get a component of production efficiency in there as well. But for the purposes of really changing the absolute methane, that is what's our government is demanding of us, methane yields where we have to focus. So the ultimate goal is to improve methane yield, but at the moment, we don't really have sufficient feed intake data available in our sheep full stop, let alone put against methane. So that's something we need to work on. It's a little bit of, I guess, a hole in our data or a research question that hasn't really been asked yet. We've just been measuring methane, and we could actually be just improving production efficiency, or we could be improving methane yield, or it could be a bit of both, and we don't quite know that at the moment. There's another thing there about yield being a ratio trait, and most people in the room know animal breeders hate ratios with a passion, I should say. They've got very poor statistical properties, and where you end up when you select on a ratio always depends on the relative variation of the top line versus the bottom line. So it is predictable if you know that variation, but it's not necessarily related to where you want to go. So we need to use a proxy for feed intake, at least for now. And what we have found is that using, if you fit live weight, which typically we'd say, right, live weight's the proxy of feed intake. We know that actually using our CO2 data that comes out of those chambers on top of live weight actually does give a better prediction of feed intake than live weight alone. So at the moment, our thinking is that we'll use live weight and CO2 as a proxy of feed intake, at least for now. And it's not perfect by any stretch. So then we have some options, right? So we could pre-adjust methane for live weight and carbon dioxide. So adjust it, do those adjustments before it goes into the breeding value analysis. That's one option. Another option is to post-analysis adjust the methane BVs for BVs for live weight and BVs for carbon dioxide. So it's already gone through the analysis and you post-adjust that. And one of the things that you've got to be aware of when you do that is you start to have issues around accuracies. So different animals have different levels of recording in their background, and they'll probably all have a similar-ish accuracy for methane, but they might have widely different accuracies for a live weight, for example. And that actually starts to play into what adjustment you get. So Peter Amer from Abacus has come up with this methodology that he's used in several instances, and it's called, well, he calls it DAS, which stands for de-regress the EBVs, make the adjustments, and then shrink them again. And that's the sort of a methodology that he's applied to really try and get at that issue about different accuracy EBVs when you're using adjustments. It's a bit of a technical thing and it's a technical nightmare to implement, but there you go. The alternative is to just, as I guess has been done in the research scenario, just use absolute methane in an index alongside production traits. And there's pros and cons of all of these. So I'm probably more in favour of making an adjustment. And the reason why that's my personal opinion. It's not universally held amongst everyone for sure. I just find, I guess, in a lot of sheep breeding, they don't tend to look at the absolute breeding values or the biological breeding values. They look at the indexes. But coming from a cattle breeding background, I want to see the biology and I want to understand the EBVs. And I think, to me, that's what we should be doing. And it's the same argument about feed intake versus residual feed intake, right? When you've got a methane BV and it's reasonably highly correlated to a growth rate BV, for example, it's really hard in my mind to actually get a feel for where that variation, where the residual variation is sitting and the relativity of those two traits. So that's my personal bias, and I come from a feed intake background, so I'll probably bring all my biases into that. But at the end of the day, as long as you do it right, it shouldn't actually matter which one you do. But that's the theory, but there are always practical implications. So the last thing I want to talk about, and this is again a slide taken from Ministry from Primary Industries, and what this is describing is the approach that New Zealand is taking around emissions in general. So the idea is that every farm, and at the moment 83% of farms, will calculate their emissions across their entire business. And there will be a standardized calculator that will do that. So MPI and AgResearch are working on that calculator, and it will take all sorts of inputs into it, and basically says, well, for this business, for your business, this is how much emissions we are expecting you to make. And that's not just genetics, right? It's everything. So the question then becomes, well, okay, how can, at a commercial level, how can I get credit for going and buying some rams that are better, more methane efficient, essentially? So, because unless we have some sort of incentivization, we're not going to have any pressure put on that trade at all. So the idea is that this calculator is going to exist, and this is a horrible, complicated diagram, but essentially what it's trying to represent is, and I'll start here, there's some performance recording, the data goes into our New Zealand genetic evaluation, there's some rams selected which ideally are more efficient for methane, and then those rams are then sold to a commercial flock, and that commercial flock can actually keep a track of their ram team over time. And as you go along, these white animals represent some level of improvement, and over time keep on buying improved rams, and you'll end up with a flock like that. But how do you prove that? And so what we are planning to do is, alongside our genetic evaluation, is to sort of create a ram register where people can say, hey, these are the individuals that I bought from my property, and I've used them for, which rams did I use this year? And then use a gene flow model to essentially predict, just based on the rams that I've been buying, and on a few other factors, such as, flock age structure and that sort of thing, basically predict a flock level EBV, EPD for those things. And then the idea is that flock level information can then be passed into the calculator that I was just talking about. And so, it might say my sheep genetically are 5% better than what that calculator is doing, and than what the standard sheep in that calculator would be. And so that calculator could take that information in and give me the credit for that 5%. So that's what we're thinking about at the moment. The good thing about that is, if we're doing that, then we might as well do it for every trait, and actually have our commercial farmers starting to understand what their genetic profile really is, and hopefully have that influencing their ram breeding decisions, not just for methane, but for all the other traits as well. And actually, you could use it as some level of diagnostic, right? So if I've got, so in sheep, obviously you have multiples. So the example I often use in sheep is, if I'm struggling with my scanning percentage, so the number of twins on board, at the moment I don't really know whether it's my genetics that are holding me back or my management. But if I had that flock level EBV and I could compare it to other people, I could say, well, actually, my genetics are fine. I'm right up there in terms of genetics. I'm just a really poor manager. Or vice versa. It might be, actually, I'm a good manager, but I just haven't been buying the right rams. And you can imagine similar thing with, say, marbling, expression of marbling in cattle, right? So what's my marbling level? Is it because of my genetics, or is it because of something I'm doing in my management that's limiting the potential? So I think it's got other benefits, but we will do that with the primary purpose of the primary funding for it as a methane thing. So what might be different in cattle from sheep? Well, probably not a whole lot. Once we've got a pattern that we've worked out for sheep, I think we'll tend to go along with it. Obviously, one difference is the methane chambers, and these chambers that I showed, and I won't show the video because I showed it this morning, but Obviously, they're bigger. They've been designed to hold an animal up to 450 kilos, which is 950 pounds, something like that. If we want to put bigger animals through there, we're going to have to re-engineer the box a bit, because it's not just about the capacity of the animal, it's actually about the airspace in the box. You've got to have enough airspace in there that you don't hit CO2 levels being too high after too short a time. But obviously you don't want too much airspace in there, or else the actual changes that you're getting in the gas concentration are small and non-detectable. So there'd be some work to re-engineer the boxes if we were going to do that. And as I said this morning, these things are movable but not portable. So that will be a problem that we could solve. Everyone thinks of a solution. At the moment we're thinking, well, maybe we could get a 20 or 40-foot container and take the sides out and put them in there and just tie a bit on and off a truck or something like that as we took it around. But who knows? Or maybe they have to be in fixed sites and people bring the cattle to the chambers. So yeah, actual phenotyping might be a bit more of a challenge. What we will do well is the feed intake stuff. So ironically, feed intake in New Zealand is a long way behind, and really it's just in the last 2 or 3 years that we've even had anyone doing feed intake, and there's only three facilities now. One that are owned by cattle studs. Will sitting there's got one of them. Just incidentally, so that blue that you can see in the background behind those animals, that's the ocean. So these animals get a holiday by the beach when they're on their feed intake thing at Tamania. Other differences in beef. So one is the breed structure and the way we approach them. So in sheep, we basically have an all breeds in analysis in New Zealand, and we actually have quite a different sheep genetic population to virtually every other country. We've bred our own sheep to suit our own environment. Sheep just tend to be a little bit more environmentally sensitive, I think, than cattle. So the lots of the Australian sheep are completely different breeding, essentially. So it does have implications, whereas cattle has tended to be within breed analysis in our part of the world anyway. So then how big a reference population do we need, and how do we go about getting that? And then another part of that, though, is, in cattle for us, a lot of our cattle genetics come either from the US or from Australia, and a few from Canada as well. So we import a lot of genetics. So essentially our main breeds, being Hereford and Angus from the maternal point of view, are really well connected to the international populations, and there's a big opportunity to do a lot more international collaboration and share the load in terms of having these reference populations. So that would definitely be something that we will be aiming to do in cattle. And then, as I mentioned before, the practical approaches to methane measurement on seed stock properties is probably a challenge that we need to think about a little bit differently to sheep. So where to from now? There's still a lot of technical unknowns in beef. We're really just at the start of the journey. Heritability, correlations with productive traits, impacts of age, diet, etc. But given that we have managed to do this in sheep, I'm pretty optimistic that actually it's going to be possible in cattle. And I know there's work over here on the same stuff, and I'm sure you'll tell us the same story. But there are some key questions, and they're not necessarily technical questions, right? The how to do this cost effectively and who pays for it. How much emphasis should we place on it? And the biggest question is, what's the driver? Who's going to reward someone for the effort of doing this? So that's about all I wanted to say. So thank you. And if there's any time for questions, I'm happy to take them. Bailey.
I got your estimates for how many records population you need and how many records you want to add each year. How many breeds are represented? Like, what is that population size? Just for some reference.
I can't tell you in terms of effective population size. The question that I'd ask, the question we've got to think about is what is even a breed? Because, and what I mean by that is, yes, we've got a bunch of people that are sort of sticking to a breed line, but even a lot of those have got other breeds mixed into them. So there's a lot of crossbreeding, a lot of mixed breeding that happens even at our seed stock level in New Zealand. So I didn't do the calculations. I think John McEwen did the calculations, and he's probably got a fair idea of what the effective population size is. He could ask him for you. But yeah, that's sort of back of the envelope type of calculations, because I don't think any of this is a precise science. The answer is always the most you can possibly afford. So yeah. Mark.
But what's the incentive, like, 83% of sheep farms to convert to that?
The government said you need to. That's enough of an incentive. Yeah. Oh, sorry. The question was, what's the incentive that we have 83% of our sheep, it's sheep and beef farmers actually, because we farm them together, have at the commercial level have done a calculation to work out what their emissions are. And the answer is we got told.
So I should have asked this question this morning, too popular with Q&A. Did I hear you right when you compared, and it's been in correlation, but the rumen microflora, the microbiome was 0.6 with the methane, is that what you said?
0.76.
Okay. So would it not be easier to measure that as a phenotype and get more phenotypes and have better information, especially as it pertains to more deficiency?
Yes and no. So yes, that is the strategy, right? So get some cheaper proxies of that. At the moment, even though we know the correlation is good, the cost of doing the microbiome is about the same as the cost of measurement in sheep. So then it just comes down to logistics and ability to scale and who pays. Always comes down to who pays. But yeah, so in sheep, that's not the case. At the moment, the cost of doing a pack chamber in cattle is more like $400. And so, and a microbiome test isn't going to be any more expensive for cattle than sheep, or it shouldn't be, because you're basically the same thing. So it might be a more readily useful strategy in cattle, or the other part of it is, you know, this is all pretty developmental and it hasn't really been industrialized. There's a whole lot of costs that can hopefully be taken out of that microbiome process, and then when you scale up, you have the benefit of scale as well. So, you know, hopefully it could get down to $20 or $30 would be a lot more reasonable. I don't know. I don't own a lab coat, and I'm proud of the fact that I've never owned a lab coat, so I'm not the person to answer that question.
Oh. Get the graph that showed the trade-off between the productivity index and methane. If instead of the correlation on the index, on the left-hand axis, if you put actual economic index units and you put the absolute amount of methane on the right-hand axis, how does that graph change?
It's the same shape. It's just on a different. The units are different, right? It's a scale thing, right? So that's just the way that particular graph has been scaled. Absolutely.
You know, how many dollars am I giving up here? Not how much is the correlation.
Yeah. No, totally agree. Yeah. But the shape will be identical. The shape is the same.